you're flipping it over, just a reminder, we had talked about isotopes and ions. So we were able to recognize an isotope versus an ion, and we had to answer these questions down here. Okay, so this is on the back of the one that you guys were doing today. And so the big idea was that when you had protons, an isotope was something that had different number of neutrons, right? That was the question of the day. We had a couple people banging their head on their desk. I was like, I know you know who I'm talking about. So I know it was too much for a Friday morning, but we did talk about that, and so it affected the mass number. That's going to be your lab tomorrow. So what I'd like to show you is the ultimate calculation for your lab tomorrow, just so that you kind of know what's coming, and that way when you see it again tomorrow, it won't be as overwhelming. Okay, that's my goal. But the other one that we talked about was ions, and ions were when you had a difference in your protons and electrons. So for now, it was just about recognizing that. We'll come back to like how to fill out one of these tables later, okay? So when you flip your paper over, you have something, it says average atomic mass, all right? So I'm just gonna have you guys write in a couple facts here. I am recording this so that you guys can come back to this tonight if it kind of goes over your head, okay? Let me see what I wanted to put. All right, so an average atomic mass. So remember, average atomic mass is the thing on the periodic table. So this is the mass. I just want you to write it really small right here. Mass on periodic table. Just put mass on PT. That is where it comes from. It's an average, and that's what I kind of got you guys to see on Friday, was that I said, okay, so why did that one element have the 0.305? Where did that come from? And we kind of put it together. Looking at the isotopes, it was based off of a bunch of isotopes of the same element, different flavors of the same element, right? Different number of neutrons. But we had to do a weighted average. So if you remember, the picture that we looked at on Friday was the one that looked like this, right? And I asked you guys how many of each ones there were, right? I said, okay, so how many 24s were there? How many 25s? How many 26s? And you saw that there were less of the 26 and 25s, but more of the 24s. Because of that, that mass that was on our periodic table was a lot closer to 24 than the 25 and the 26. All right? Now I've just managed to say a bunch of numbers, and I'm already seeing eyes glaze over. So let's just move into this so that you guys can see where that number comes from, okay? All right, so remember, it's based off of isotopes. So what we're going to be doing here, actually right next to your little thing where you said mass on the periodic table, just put a weighted average. You have to put that word weighted, okay? It's a weighted average. And the thing to kind of relate it to is how you would, if you were just given a copy of all of your individual grades for quizzes, tests, and labs, you could technically calculate your average. So at the end of this, you should be able to calculate your average, okay? Okay, I'm going to fix my camera real quick because it's really far away from this paper and all the zooming in is not going to be working very well. That's so much better. Oh my gosh. Okay, there we go. So it's a weighted average. So we're going to just really quick just put a how-to for how to set up. And then you learn it more when we start doing the examples, okay? So just remember that. It's going to be a little weird right now, okay? So this is how you're going to be setting things up. When you're doing weighted averages, just like in that picture that we were talking about, that you had a certain number of each one, right? And we had a certain isotope or a mass number, right? Just like that, we have to consider those two pieces of information. So you're going to be given a percentage. So just like I made you count how many of the 24s, 25s, 26s, we were in our head saying, oh, percentage-wise, that was less than this one, okay? So you're going to take your percentage, and you're going to move decimal to the left. What did I just do? If I move a decimal 2 to the left, what number did I divide it by? 100. So we basically are taking a percentage, which means out of 100, and we were just changing it into the decimal form, okay? So when you get your percentage, you're moving that decimal to the left. Okay, that's your first thing. Next, you're going to multiply by each mass. And it's going to end up looking like the mass number when you first start out. But you're going to see tomorrow in the lab that it's not the mass number necessarily. It's actually what they weigh, okay? So multiply by each mass. Last step, add up your answers. Okay, so just have that written, and then let's move into an example. And I know you guys are out in about 7 minutes, so we should be able to get through one whole example. So at least you have this to work off of tomorrow, okay? Okay, so we got that little part written. And if not, like I said, I'm recording. You can get it again tonight. All right, so let's look at our little question right here. So we have calculate the average atomic mass for neon. Okay, so neon is on our periodic table, so we can always check our average atomic mass of neon at the end, right, on our periodic table. Okay, if its abundance in nature is this, this, and this, right? So we see that we have percentages, but then I give you names. Did I talk to you guys about what hyphen notation kind of looked like? Kind of ish, yeah? Okay, so what was this number that's right here? It's the mass number. It's your mass number. Okay, it's how you identify isotopes. So in that picture that I keep showing you, this would be magnesium 26, magnesium 24, magnesium 25. Okay, so those mass numbers, that's all that is. Whenever you see the hyphen notation, that's what we're talking about. All right, so cool. So this is our mass number, and this is our percentage. If I give you an actual number that has a decimal, you have to use it. Okay, but otherwise, if it's like this is usually what we give you. That's what you're doing. All right, so we're going to do exactly what it says. We're going to move all of our decimals to the left. So the best way to set these up is like a table. So we're going to go ahead and say 90.5 is your first percentage. Okay? You can put that there. That way you know what you're talking about. We have a 0.3%, and we have a 9.2%. So just list those out. We're going to do step 1. We're going to take those decimals. We're going to move them 2 to the left. We're dividing each one by 100. So we're taking that 1, 2, 1, 2, 1, 2. So what that means is we get 0.905. This one we have 0.003. I had to think for a second. And this one we have 0.092. If you are nervous about moving that decimal 3 or 2 to the left, then just go ahead and divide by 100 and you'll get the right answer. All right. Next thing, it says multiply by each mass. So we're going to just say multiply, multiply, multiply. This one was a mass of 20. So we're going to put 20 right there. The 0.3% was a 21. The 9.2% was 22. Okay. You can use a calculator. I'm not going to hand out the calculators yet today. We'll do it tomorrow for sure, but I can get it for us too. All right, there we go. So I'm going to basically do 0.905 times 20. We get 18.1. The next one, 0.003 times 21, we get 0.063. And then we have 0.092 times 22. We have 2.024. What's our last step? Add up all of those answers. So let's just see if we get what's on the periodic table. 18.1 plus 0.063 plus 2.024, 20.187 AMU. That's atomic mass unit. What's on the periodic table? I don't have mine next to me. Yep, there we go. All right, so there we go. So that's going to be the process of doing this, okay? And like I said, I just recorded that, so I will be posting that so that you guys can write it down again later. Otherwise, let's go ahead and you guys can pack up. You guys got 3 minutes, all right? Eva? Well, I was recording. Hold on. Am I still recording?